We're working in section 3.3. We're finding the zeros of a polynomial. In each of the previous examples, we're always given one of the zeros to get us started, and then we just find the rest of them. But what would we do if we didn't know any of the zeros in the first place? The rational zeros theorem tells us how to start. It says that possible rational zeros are of the form P over Q, where P is a factor of the constant term and Q is a factor of the leading coefficient. So let's look at an example. Example 4 says f of x is equal to 15x cubed plus 14x squared minus 3x minus 2. Do you know which is the constant term? The constant term is negative 2. So it's here at the end of the polynomial, and then the leading coefficient is up at the beginning. It's the 15. So the possible rational zeros have the form. Here, let's work over here where we have a little more space. So the possible rational zeros have the form factors of negative 2 divided by factors of 15. And factors of 2 are 1 and 2, and we always want to consider positive or negative for all of our factors in this problem. Factors of 15 would be 1 and 15, and it would also be 3 and 5. And again, we need a plus or minus on each of the factors. So now what we're going to do is we're going to take each of the combinations of a factor from the numerator over a factor of the denominator. So let's be a little bit systematic about this. Let's just work with the denominator 1, and let's do all of the numerators over 1, and then we'll do all of the numerators over 3, and then all of the numerators over 5, and then all of the numerators over 15. So from the beginning, 1 over 1, and then 2 over 1. So 1 over 1 is 1, and it's positive or negative. 2 over 1 is 2, and it's positive or negative. Then we'll go on to the denominator 3. We'll do 1 over 3 or 2 over 3. And then we'll do 1 over 5 and then 2 over 5. And then we'll go to the last denominator, 15. We'll say 1 over 15 or 2 over 15. And that's our answer for the possible rational zeros. If the function f of x has any rational zeros, then they are in this list. And it's possible that that none of these work, that none of these are zeros, but that would be a problem for some other day, for a more difficult course. In our problems, some of these possible zeros will work. So let's go on and let's go ahead and figure out what the zeros actually are. So in part B, find all zeros for the function. So what we're going to do is we're just going to start checking. And how will we know when we find one? We'll know we found a zero when we do the synthetic division and the remainder is 0. So let's see here. I guess we could start anywhere in this list. Probably the best place to start would be with 1 or -1, and then 2 or -2. And then we'll get into these fractions if we have to. But we haven't even done any synthetic division with fractions before. We could, but hopefully it won't even be necessary for the problem. So let's see. So let's try k equals 1. Let's try that again. Let's try k equals 1. And so we'll put a 1 outside, and we'll put the coefficients inside. 15, 14, -3, and -2. And then we'll go through the synthetic division. I guess I'll go through pretty quickly. Since the remainder is 24, then 1 is not a 0. We need to keep trying. Try k equals -1. Put a -1 out in front. 15, 14, -3, and -2. And then we'll have 15, -1, +1. This is looking promising. This is 2, and this is 0. So that worked. So we know that -1 is a 0. Now, do we need to keep checking the rest of the possible rational zeros? No, we don't. What we need to do is use the division algorithm to go ahead and factor f of x, So let's do that. So let's find a little more room here. And then remember, if we're trying to find the zeros, what we're doing is we're solving f of x equal to 0. And so let's see here. Let me rewrite the function. The function was 15x cubed plus 14x squared minus 3x minus 2 equals 0. And the division algorithm says that we can factor that as x minus k, x minus -1 or x plus 1, times the quotient. The quotient is 15x squared minus 1x minus 2, and all that is equal to 0. And so now we have a linear factor, x plus 1 equal to 0, which gives us a solution, a 0 at -1. We already knew that to be the case from our synthetic division up above. And then the other zeros are going to come from the quadratic factor, 15x squared minus x minus 2 equals 0. And so we can solve that by factoring, or we could use the quadratic formula if the factors don't come to us right away. I like to do the factoring in my head, usually. And so let's see here. If you have 15 can be written as 3 times 5. And then 2 can be written as 2 times 1. And if you put the 2 over here and the 1 over here, then the two middle terms are going to be 6x here and 5x here. 6 minus 5 gives you the -1x in the middle that we're looking for. So let's put a negative sign on the 2 and a positive sign on the 1. And I know I went fast through that factoring. Take your time and make sure you feel good about those factors. Okay, last step. Take the linear factors and set them equal to 0. solve for x. 3x is negative 1, so x is negative 1/3. Or 5x is 2, so x is 2/5. So we could box those up, and we're done. I'd like to just point out one more thing before we go, and that is there are actually 3 rational zeros, right? Negative 1/3 is a rational number, and 2/5 is a rational number. And if you go back up and look at your answer from part A, you see that negative 1/3 and positive 2/5 were in our list.